Okay, let's do problem 2 of 5, isomorphic strings. Here we're given two strings S and T and have to check if they're isomorphic. Isomorphic is nothing but one-to-one mapping of each letter. So just to understand the problem, let's have a look at these two examples and try to come up with our logic. So here in example 1, all we need to do is just make a map and add those mappings. So we are looking at E and A. So this will contain TS and then the value will be the character T. And then we are going to look at G and D. Okay, so we add G and D. Then when we go to the last element, we have to map GRT, but it has already been mapped, so S and T are isomorphic. But when we look at the example 2, it's a bit different because F and B, okay, we can map them. We can map O and A. But when we go to the last element, O has to be mapped to R, but it has already been mapped to A. So in this case, it's not isomorphic. So what's the logic? So obviously we need to have some sort of a map, and then because S and T are in string, we want to convert them to character arrays, and then we have to iterate our character arrays, and we are literally going to update our hash map. So the way we update our hash map is we have to make sure that the S is not in our map. So if a map does not contain key S, we have to update. What do we mean update? That will be put S and T into our hash map. And what happens if there is already key in it? For example, when we look at this example, we would have updated our map like this: F and O, and F and B, and then O and A. And when we go to the third iteration, okay, O is in the hash map because it's in the we can find the key value of S. But we also have to check if the corresponding value of that of the hash map is equal to the value we are looking at. So else if the map.get, so map.get returns the value. So map.get of the S character is not equal to the character we are looking at, T, so it will be character at I. In that case, we return false. Okay. But there's one more thing to consider. So suppose we're looking at this example, we would update B and A, B to B, A to A, B to B, A to A. Now, if we follow our logic, let's have a look at the third letter, D and B. Okay, so D, we do not contain the D in our hash map, so we just put D and corresponding B in our hash map. But it's incorrect because we can see that B has already been mapped. So here we also have to check if map does not contain the value of T. If it does not, we put them in, but else we have to return false. Alright, so that's pretty much the logic for it. When we explain it, it sounds more difficult, but in reality it's a lot easier. So here we are going to convert our S and T into our character. So I'm going to call it S car equals s2 card array, and we're going to convert t into our character, so t to card array. And then we do need map, so I'm gonna, but map will store characters, so I guess map of character equals, I'm gonna call it word map equals new hash map, and that. We're going to iterate our s character, so it will be s int I equals 0, I is less than s card.length and I plus plus. So if word map does not contain key of s card.I, it should be does not contain. If it does not contain, and if the word map does not contains value of s t card.I, in that case we put those values into our map, so it will be s card.I and t card.I. But if they do not contain s, but if they contain t, it means there has already been a mapping for t, so we just return false. And if it contains s, we have to compare if the corresponding value is equal to the letter of t we are looking at. So else, if t card.I, the character we're looking at, is not equal to word map get s card.I, we just return false. And if they are equal, we don't need to do anything because there's already been a correct mapping. And if everything passes without executing the return false statement, we just return true. Alright, let's run the test. It's passed, let's submit. Alright, now we picked 75%. There's another method and I'm gonna go through that in the next one.